Okay, good to go. If you saw me taking pictures of this place just a few seconds ago, I have to take pictures because I honestly haven't seen as many people in my whole life probably in Finland. So it's like cool. This room can take more people than there were attendees in biggest conference in Finland, Tech Days, Helsinki. So it kind of makes it a bit funny for me. Okay, welcome. This session is called BlackBelt Troubleshooting Windows Performance Issues. I've had the opportunity to speak about BlackBelt troubleshooting 4 times in TechEd already, so 2 times in TechEd Europe and 2 times in TechEd US. So now at Ignite it was time to change the topic at least a bit. So I really like the topic and the subject itself, so what I'm aiming to do is just kind of take a small portion of what I've gone through on the more general BlackBelt sessions and then drill into this certain topic. So for this year I chose it to be the performance issues troubleshooting. Just a short story. Some of you were on my session yesterday. So my name is Sami Laiho. I'm from Finland. I'm an MVP in the Windows Core OS. I train and consult anything related to Microsoft basically, but I'm concentrating on operating system security and troubleshooting currently. If you want to reach me, you can reach me easily via Twitter. That's the easiest way. If you want, you can order my free newsletter as well. I've got a few companies that I'm working for. So I'm working for my own company, which is called Adminize, and I'm working for a training company called Sovelto. And I apparently have a problem with my clicker because they probably knew this beforehand because they know that I'll be running all around nervously. So now they have a clicker that only works like 1 meter off the computer. So anyway, I'm going to exchange some business cards for swag. I've done this always. So the year before, 2013 was the first year in TechEd, then I gave out these T-shirts. Järjestelmävalvoja is the Finnish name for administrator, so that's what we use to log on to the box. I just showed that to Jeffrey Snower and gave him a hat as well. So he really didn't know that there's honestly only 8 languages in the world that have decided to translate the actual username. All other hundreds of languages have been wise enough to just translate the display name so that you can still log on to your servers with administrator, although the display name might be something totally different. But Finland happens to be one of these wise 8 countries that decided to change it. So security by obscurity. Last year we had caps. Now it's working. So last year we had caps with headlights, and now we have something for the cold weather here in the conference center at least. So in Finland, very useful. So I got about 100 of those beanies. So after the session, if you have a few minutes before you have to run to the party and get drunk, you can come here and get the beanies. But I'll need a business card and a solid promise that you will fill the evals. So with that price, you can get a beanie for. I always start my sessions by teaching people some Finnish. So we did it yesterday already, and I met a lot of people at the corridors trying to say something to me, which I have no idea what they were saying, but apparently they had been trying to learn Finnish. This time, because we're really into the operating system, I decided to take some IT terms. So if you need to work with Finnish companies, you at least know some terms related to IT infrastructure. So we're going to start with the English word of a temporary page file. That's in Finnish something called tilapäisheittovaihtotiedosto. That should be something quite easy to start with. And I just moved my data center to my friend's home. He actually has a 1 gig in, 1 gig out fiber connection dedicated line, so I moved my data center to his house. And he was really happy that he could now print on his business cards his new title. So because he is now my data center administrator, in Finnish on his business card it says tietokonesalijärjestelmävalvoja. So now you have two. You have to learn these, and then there's the third one. So to go back to the topic that I was talking about yesterday, to survive without admin rights, and even without their administrative rights, how many words do you need for that in English? And still you complain that Finnish is complicated, because in Finnish it's just this. So it's järjestelmävalvoja oikeuksillaankaan, which is, that's the end of the lesson today, and we'll get right into the topic. Okay. There's a few links I want to be shown on the video at least, so you can go and check out some of my projects if you want. What we're going to talk about today is we're going to start with some basics on troubleshooting performance issues. So just common things that you need to know. And then we're going to drill into these kind of the most common resources that you might run out of. So we're going to start with CPU, then we're going to go through memory, and then disk, network, and slow boot ups as the final one. First of all, some basics. So this seems to be more related to people using their own personal computers, but what happens all the time is that I see people asking me why their computers are working that bad. And the first thing you should always do is just get rid of your external devices that you have attached to that machine. Really basic, but you should do it, and people seem to not do it anyway. One thing that people forget often about UEFI and BIOS is that people seem to believe that UEFI and BIOS need to be upgraded if you want to get new features, or you want to get a support for bigger cluster sizes on your hard disks or stuff like that. What they tend to forget totally is that CPUs have faults. You can see Intel coming out with a new CPU, and later on they'll have the second CPU. You buy it from the shop, but it has something written next to the name which is a stepping level. And that stepping level equals to kind of a service pack for an operating system. So when they find the real faults, they fix them on the physical chip, and then they add more numbers to their stepping level. But until you get a new CPU, the only way to fix the actual faults on the CPU is with your BIOS or UEFI. Those are called microkernel patches usually, or microcode patches. So that microcode fix is something that's very important for your machine. So you should be upgrading your UEFI and BIOS not only to get new stuff on your computer, but also to make the old stuff work properly. Get the tools. So we're going to go through different tools. So I've just added them here on a single slide so you have some reference to go back to. So the built-in tools are something that are mainly used for making a first diagnosis about if you have a problem or not. They usually can't solve the problem, they can't show you what's wrong, but they will work as a first indicator of something being wrong. So Task Manager, Resource Kit, Performance Monitor. Basic tools on all your Windows operating systems since Vista. Well, actually Resmon, or Resource Monitor, got a really good upgrade from Vista to Windows 7. So to talk about the really cool Resource Monitor, then you have to be talking about Windows 7 or something after that. Downloadable tools, the most important one is sysinternals tools. If you're doing ad hoc troubleshooting, you need the live.sysinternals.com where you have the pre-extracted downloadable exe files of all the current sysinternals tools. So you can just download the executable and instantly run it instead of downloading the sysinternals suite as a zip file, extracting it, etc. So sysinternals tools comes in two flavors. Windows debugging tools. You don't have to do anything related to debugging. That doesn't mean that you should be doing debugging. That doesn't mean you should be an application developer or something like that. But debugging tools are used as a support function for most of sysinternals tools. So you just have to download it. It needs to exist on your machine. And the good thing about Windows debugging tools, which has been a lifesaver for me many times, is the fact that you do not have to install it. I actually have a USB key with me usually that has few subfolders to it because you need to have the same operating system version that you're going to debug. And you can install them on your own machine, and then you just copy the program files folder. There's Windows Kits 8.1, for example. You just copy those on a USB stick, and you can just copy them on any Windows operating system with the same OS version. You don't have to install the MSI packages or download them from the internet. So a lot easier, especially if you're talking about servers that you can't just reboot or you can't change anything on them really. So the thing is that it's easier to copy the files there than run an MSI, and although debugging tools doesn't need a reboot, sadly sometimes you have installed some software that uses common components that the debugging tools do, and it will ask you to reboot the server. And you don't want to do that if that's a production environment. Windows Performance Toolkit is part of ADK now, so it's downloadable for free, and it's the most important tool probably on this whole session. And we're going to use it for demos, and we're going to talk about it a lot. So it's probably the most important one. If you've seen stuff like XPerf, it used to be kind of so that the actual gathering of information was not that friendly as a user interface, so you had to use command line tools all the time. But with the new Windows Performance Toolkit, you can actually gather information with only the graphical tools and then analyze them with the graphical tools. So it's become easier to approach, let's say. And then if you have a network issue, then you need a network monitor. Network monitor used to be called Netmon, now it's called Message Analyzer. I use a lot of Cisco stuff myself, and I use Wireshark with my Cisco devices because Wireshark just works better with the third-party equipment usually. So I'm not saying that it's only Message Analyzer. You might be using Wireshark, but the thing is that Message Analyzer has a really cool capability of doing remote network analysis if the remote party is Windows 8.1 or Server 2012 R2. Not even Windows 8 or 2012 work, but 8.1 and 2012 R2, then you can do remote network monitoring. And if you've been with this industry for a long time, you remember that there actually was a really old version of Netmon that did that same thing, and then it disappeared for about almost 15 years. And now it's finally come back. Woohoo! Okay, the first one we're going to drill into is the CPU. And we'll start with some basics of CPUs and something that's happening on your computers currently, I'd bet. And I've taught this for a few years on all of my courses as a demo, and I see people, when I start talking about this, usually the whole classroom stops paying attention and starts digging into their own laptops and trying to figure out what's wrong with their machines. Because this is really common. Tools that can be used are quite old already, but somehow really unknown. First of all, one important thing about the CPU is, of course, that when we do troubleshooting on CPUs, we need to dig into thread level. We can't be talking about processes, as Windows is a multi-threaded operating system. That means that a single core or a single logical processor is running a single thread at a time. It doesn't mean that the process takes over a processor, so a thread takes over a processor, meaning a logical processor in this case. So a single thread, which is kind of a sub-process, you could say, is the one that we need to troubleshoot. If you've been to my previous sessions, you've heard about it, but that's like the biggest mistake that happens in any troubleshooting. People are all the time telling me that this process fails, or this process causes this. That's always wrong, because by definition of the operating system, the process can't do anything. A process in Windows can't do nothing. So English-Finnish. I had a horrible experience yesterday. You can't imagine how embarrassed I was when I was talking about Jeffrey Snower to a few other MVPs and colleagues of mine here, but when I started talking out loud on the corridor, and I didn't realize, but I was talking about Jeffrey Snowden all the time. So then Jeremy Moskovich goes like, "Sami, that's the bad guy. Oh, sorry, Mr. Snower." Trying to get it right. Okay, anyway, logical CPUs are the ones that we're looking after because those are the ones that are running a single thread. And then You have to remember something, that we're mostly now working with virtual CPUs. Even you're installing Hyper-V on your Windows 8.1, for example, and you're running a hypervisor below your Windows 8.1, which means that the virtual CPUs make things really complicated. Virtual CPUs, if you want to think about what virtual CPUs actually are for an operating system, they're more like schedulers. They have nothing to do with physical CPUs. So they're schedulers that just software components that schedule stuff that should be running on a physical logical processor at some point. But they have no relations to physical processor, which means that we can't measure them the same way. I get people all the time telling me that the Windows 8.1 is causing this CPU load, but they forget totally that they are running a virtual machine on top of a hypervisor, although it's the parent partition that they're talking about, but it's still a virtual CPU. So the concept is usually totally wrong. People believe that they can do hardware performance measurements on the base operating system. That's even wrong that they're calling it the base operating system, as it's just a host running on their hypervisor anyway. So you can't go and measure your server's CPU load and say that your CPU is taking this much. That's not a real CPU. You're still running on a hypervisor. So you have to change the concepts totally, but we'll get back to that later on. One first thing I'm going to talk about is quantums. And when a Windows operating system runs a single thread, it gets a quantum of time. Few quantums by default, so actually 2 quantums by default. And these quantums by default are 15.6 milliseconds. So for 15.6 milliseconds, and actually by default for 2 times that, so about 30 milliseconds, a single thread can execute something on your box. And then it's someone else's turn, if someone else is in the queue. Now, Windows has been built from the ground up to work so that it knows that 15.6 milliseconds is the smallest amount of time that someone allocates to themselves. Meaning that all your power configuration, all your power management, everything relies on the fact that there should be these gaps of 15.6 milliseconds that they can rely on. And now the bad thing is that the software and the applications mess it up totally. Let's see this in a few ways. So, this one. So let's take the first demo on quantums. I'm going to change for my demo machine here, and you should see this. So my machine here is actually my production machine. It's not really running anything except for the remote desktop connection to another box here on the table. And if you want to see your current, if you want to see the length of your current quantum, the easiest one is sysinternal's tool called the clock res. So if we run clock res here, we can see that it is the 15.6 millisecond maximum timer interval and a minimum timer interval of 0.5, but actually I'm running at 1.0 milliseconds, which is 15 times faster than it should be. That means that if I have a timer waiting for the next opportunity to do something, it's actually triggering 15 times faster than it should be. So kind of easy way of thinking about it. Your computer, if it's doing something and then it decides, for example, to sleep a processor core or sleep a whole socket or something like that, it knows that for 15.6 milliseconds it can do that, because that is the time that you have. But when you change this, what happens is that your operating system starts going like this. Well, a bit faster than that, but hopefully you get the point. So that's bad for a lot of stuff, especially for power management. Now, why is it 1? I'm quite sure that many of you have read the news about one company, which if I mention them aloud, as Jeremy says, I'm going to catch fire. So I can't, but it's kind of somehow related to the search engine of your choice. So, okay, I'm going to stop that. There's no way I'm going to be able to do that. So let's try this. And we have Google Chrome, but now you see Google Chrome is not running. Google Chrome is very popular for messing up your intervals. So what does this do? The thing is that Google can honestly say, They're not even cheating if they're telling you that Google Chrome is actually 15 times faster than IE. And that's true and easy to measure. Now the thing that they're not telling is actually that if you want your IE to be as fast as Google, you just have to start Google Chrome in the background and then your IE will be 15 times faster as well. Because the thing is that if an application asks for a shorter timer interval, it will affect the whole operating system. This cannot nowadays be done per process or thread. It always affects the whole OS. But now, we're still running one, as we can see, and we're going to shut down Google Chrome. Google Chrome has nothing to do with it. They actually told and actually fixed it in a latest release. It's now fixed. Now they say that only when you are actively browsing something with the browser will it drop down the interval. But if you leave it so that it doesn't do anything, they raise the interval back. Because people got really mad because you could see like my Fujitsu losing hours of capacity on its battery if I was running Chrome or not. So that's I'm traveling all the time. That's ridiculous if I choose a browser and then I lose my battery life. So, well, it's not a problem because I always use Internet Explorer anyway, so I'm going to get points for that. Okay, there's stuff running here. Process Explorer is running here. Process Monitor is running here. Let's see if it has any effect. No, still one. We got a remote desktop connection. Maybe these could be multimedia processes. For example, videos usually drop this down like media player so that you can get a better refresh rate on your videos. So that's what it's meant to do. Now Google is playing like with that function which was mainly meant for multimedia processes. So now we're kind of gotten rid of everything except the command prompt, but we're still up one. You have to trust me when I tell you that there is not another user logged onto this box running Chrome or something like that. That's all that's running is what you see now. And actually the answer is on the screen. It's visible on the screen. So anyone want to take a lucky guess? I heard someone say it, yeah. That's my favorite tool, or it used to be. So it's actually Snagit. So I'm using it for all the capturing for my materials and stuff like that. Even these materials have screenshots that have been taken with Snagit. But Snagit actually lowers your whole operating system's timer interval permanently to 1. We can check it out. If you want to know what's causing this on your box, there's luckily a built-in tool. powerconfig/-energy. And then you can do, if you just run this, it'll take 60 seconds, because it'll do a 60-second monitoring time period, and then it will show you the results. So what you can do is you can actually put duration, and for example 5, so that's 5 seconds only. And if you run it like this, it will save a energy-report.html on your system32, and if you've tried it, i.e. Chrome, they don't like opening HTML files from system32. So you shouldn't do it there. So there's actually an output parameter which we can use here. So ctemp ignite.html. And let it run for 5 seconds. You can run it for 60 seconds better, but for demonstration purposes I'm going to lower it anyway. And to catch this sort of activity, 5 seconds is enough. So now we start looking at what's happening. It's going to tell me that I'm plugged in, I have no power management on. That's normal for a presenter here because we turn off every single thing that might be causing a sleep action or something like that. But if you go down a bit, you see what we're looking for here. So here you go, warning. Platform timer resolution is now down to 1, although it should be 15.6. And then there's who actually asked for it. So Snagit32 is to blame. I'm still saying it's the best screen capturing tool out there, so no Snagit people will get pissed at me, but I have a tendency of doing it. This, like yesterday, I did it for another manufacturer. They're all going to hate me. Okay, let's turn Snagit off. So, nowadays, there are a few MCTs at least here and other instructors and trainers and people showing and taking this, showing PowerPoints and taking screenshots. So what I've actually changed now on my own machine is that I don't anymore allow Snagit to run automatically on my Windows startup. So that's what I've changed in the settings, that it will now have to be activated manually. And if we go to clock res, you can see that we're now back in business. So that's how Windows should be working. It's 15 times slower, kind of. But the reaction time might be quicker with 1 millisecond, but the thing is that you just lose so many things that are built by the rule that they trust that it is 15.6. Because if there's something that needs to be working on a machine to even have computers, it's the clock, as we know. Everything stops if the clock stops. So now you mess with the clock. That's bad. Okay? Question? Sorry? Why did Snagit make the change? That's the question. It does it because of trying to be better at capturing, for example, video. Because Snagit can capture video and graphics. So it's trying to react faster to the changes on the screen. So if you have something changing on the screen all the time and Snagit wants to react faster to those changes, it's lowered it. So it's kind of a multimedia process in a way, but it's capturing multimedia instead of showing it. Okay, that's the first thing about quantums. Maybe I should show you one thing which is funny. Let's go back. sysdm.cpl. So your system properties, and we don't have zoom it on, and I can't live without it, so we'll have to start that first. And let's go here. Let's see a setting that I bet you all have seen since 1993 if you worked with NT at that time. I started my career back in 1996 and I've seen it many times. But it took quite a long time to figure out how it actually works. So what I'm talking about is this. That's a way old setting in Windows. I don't know why you know, sometimes when I always ask people questions, it seems like, I feel like you might think that I don't know and hope that you know, but I'm still going to give you a shot. Who can explain what this does? It's quite easy probably to figure out it doesn't do anything that it says on the screen. If you remember my previous sessions, I always started those by telling that the only logic in Windows is that there's no logic. And this is one cool example of that. Okay? Adjust for best performance of programs and background services. I, at least for a long time, thought that it actually means that if you have it on the left-hand side, it means that your foreground processes get more priority, and if you have a server, it's always by default on the background services, so then the background services would get more priority. But it actually only changes the quantum. It's the only thing it does. So by default, if you have it on the left-hand side, then a single thread gets a default quantum of 2 ticks. A tick is what they call a 15.6 millisecond time interval. So by default, if you have it on the left-hand side, all your threads get 2 ticks. And if you move it to the right-hand side, every thread gets 12 ticks. Why is this happening? It means that if you are using your computer and you are interactively all the time doing something on your box, it's really quite hard, for example, for your background, let's say printer spooler or something that someone else is using, to get its turn to actually be able to serve the people who are trying to use it behind the network. Because whenever it started doing something, you have already stopped it by doing something. Now just raising the quantum means that when the spooler gets its turn, it has a bigger probability to be able to serve people who are using it. But it doesn't know the difference between a background service and a foreground program. There's no such thing built into this. Now we're going to get back to the slides. There is a question which I didn't hear. Who was it? Oh, you have a mic. Oh, thanks. That's a proxy. Sluggish proxy. No, sorry. So the question is that does installing Chrome on a server really mess it up? Keep it off. Well, I'd say yes. My opinion would be that you wouldn't install that on a server. But now we have to remember that servers work in many different kinds of roles. So one of them, of course, being, for example, remote desktop services or Citrix, which basically you need to have the browsers there. I'm not sure about Firefox, for example. I haven't even tried it. IE has a tendency of sometimes, I haven't had the chance to hear from the product group how it really works, but IE has a tendency of sometimes dropping that timer also, but it drops it to 4 milliseconds, and I can't reproduce the way it acts. I have no idea how it works. But IE does it for 4, so it's not only 1 and 15, you can choose something in between, and as you saw, there's also 0.5, which would be even worse than what Chrome does. Or snack it. Just my opinion, not working for Microsoft. Personal opinions here. Okay? So basics about high CPU load. So the bad thing, of course, about a high CPU load is usually the fact that it's bad applications, bad software, meaning that you really don't have any way of fixing it. So only thing we can do is we can try to pinpoint the problem and try to help the developers work to be a bit easier on finding what's wrong. But we can't really fix it. There's usually no way of fixing it. There's only one way, kind of, if you want to try to alleviate this, like to have a small band-aid to fix it temporarily. Windows servers have a feature that you can install called Windows Server Resource Manager, WSRM, which can actually set quotas on processes so that they will be limited on how much CPU they can use. But still, it would usually just use the whole limit. It doesn't fix the problem. It might help you for a while, but it doesn't fix the problem itself. When you find anything that you suspect is causing a CPU trouble, first of all, a few things you always do. One, check the signatures, verify them. So Process Explorer, for example, perfect with that. Process Explorer nowadays has something called Virus Total, which you can use as well. And I can show you a short demo on that. So if we'll go here, and let's actually start Process Explorer first, because it will take a while, I know. Trying to make my computer quite slow so we can get some demos done here. So intentionally this will take quite a long time. So we should see it after a few seconds. Here we go. Here you can see this one here, Virus Total. So Virus Total is a new thing in Process Explorer. Well, it has been there for like probably a year. But what it does, it takes hash values of your running binaries, sends them out to a service that uses currently a bit over 50 different antivirus engines to check if that is something that you should suspect to be malicious. Mark Rusinovich has a great acronym for this, because he said on his session that this is like antivirus as a service, so it's ASS. So luckily we have some ASS built into Process Explorer now. If you click on those hyperlinks, you can see the actual reports from antivirus, but there doesn't seem to be that much wrong on the computer, luckily, so we're in a happy place. Process Explorer verifies signatures as well, but you have to change the settings to tell it to verify the signatures. And if you have something that doesn't clear the verification, that's instantly something that you should take a look at. We probably all know what signatures do, so if something misses the check, that means that someone has tampered with the binary, most commonly. Okay. One thing you should notice, which is really simple, but I see this all the time, is the fact that if you're running, this is kind of a new task manager, so that's probably Windows 8.1, but if you're running task manager, what you should do is that you should actually click, as you can see on the screen, there's show kernel times. And after you click show kernel times, you can see the change on the right-hand side where you see this quite low bar now. But there's that chart down there, which is the kernel time. Because now CPU causes load on either user mode or kernel mode. And that's a really easy way of you kind of quickly pinpointing on what you should be looking at. Because if you have high kernel time usage, that probably means that you're dealing with a bad driver anyway. And if you have a high usage on the user mode, that's usually a service or an application. Services don't really run in kernel mode, but drivers do. So just an easy way of pinpointing where you should be looking at more. If you want to start digging into more, one very good thing is you can use performance monitor, but that's kind of tedious if you ask me. So just if you have 8.1, even Task Manager can show it. But if you're running an earlier version of Task Manager, then you have to have Process Explorer. But either one of those can nowadays show you this one, which is interrupts. And that's something that Task Manager wasn't able to show before, and it was something that everyone was laughing about because Task Manager had no idea if drivers were using your CPU or not. But now it does. So there's system interrupts value on Task Manager as well on the 8.1. So if that goes to a value of more than 10% of your CPU, then you should investigate. That's a common, easy rule. If that's over 10, you investigate. Otherwise, leave it alone. Doesn't matter. How do we investigate? I'll show you in a second. Oh, whoops. I honestly remembered I had another slide after that one. Let's get back. Okay, now you can see this. Let's try to generate something. So I'm going to open up another machine here. I closed it because I wanted you to be sure that the remote desktop services wasn't causing the interval change. So we'll have to get back here. I've got a Windows 7 box here. Most of these demos that I'm showing you are either on 7 or 8.1 because of just the fact that those are the platforms that I found these things on. So I have to build these I want to build these from real-life cases, so that's why you see a lot of Windows 7, because Windows 7, although I'm not sure if that should be told here, it still has over 50% of the market share. So most of my customers really are using Windows 7. That's why you'll see Windows 7 in quite many examples. Let's simulate some driver activity on this one. We'll do it in an easy way of showing how Process Explorer can save your life and Task Manager has no idea what's happening. So let's start both, just out of interest. That shows us a huge CPU load currently. It should be going down in a second because actually I hope I remembered to shut something down. Let's see. Yes, it doesn't really show that much of any activity anymore. That's good. Let's leave this here. And then what we'll do is we'll do a simple dir command over the network back to our own machine. So let's dir this out. So I'm going to dir localhost $/s. Let's leave that running in the background. And we can see the CPU going up. And if we look at Windows Task Manager, there is no way of you telling what's happening. It has nothing to do with the con host. That's the host process for command, prompt, and PowerShell. So it has nothing to do with that, really. That's the simulation, yes. It does get this system here up to more than 10% value. But that's the best indicator you can have on a Task Manager. If you go to Process Explorer and check interrupts here, you can see there's some interrupt activity happening, maybe not as much as I hoped for. Quite powerful machines. So let's go here and see properties, and let's then go and see threads. And now when we start looking at the threads, you can actually quite easily see, well, just when I clicked that, NTOS kernel went up there, but if you look at these lines here, that's quite easy to spot that it's actually srv2.sys that's causing most of the activity here. There is NTOS kernel doing something, but yeah, that's fine. It has to be doing something. It's the kernel. So you kind of need to have an eye on what's normal activity and what's not. So in this case, that is the only sys that we can really see on the up level there. So srv2.sys, probably you know what it is. And if you don't, you can at least dig some information straight from here. So you can take srv2.sys and click on module, and you'll at least hopefully find some details on what we're talking about. So now we are talking about SMP2 server driver. So server message block, a known file transfer protocol. Okay? That's a too easy of an example. So we'll have to take something that's way harder to find. So I'm going to show you some examples of those as well. Actually on the base machine here, which is a term I shouldn't be really using because we're running on a hypervisor, as I said. We got a picture here. That's actually a screenshot, which is, whoa, very small. Let's try to get that at least a bit bigger. Hopefully you can read something from it. I tried to use Snagit and emphasize it a bit at least. So you should see a driver name. So what I've actually done here is from a machine that's not working properly, and our blue screen analyzers or crash analyzer, dump analyzer, whatever you're doing, can't show you the driver that actually is the cause of your blue screen. What we're digging into this is actually a memory dump. So it's a dead machine. The memory dump and the thread that was executing on the machine currently had some opened interrupt request packages, ERPs. So we've gotten the number there. That's an open request for an I/O package. And then we use the kernel debugger with bang IRP and the address of that, and we can find that the driver's name is something called MSGPIO-Win32. I had no idea what that is. I don't know if you do, but I had no. And I will tell you that this one really freaked me out. This is so scary. And it's kind of dirty, so it means that I'm only showing it to you now because I know you're all going to the party anyway after this, so we can do this here, otherwise I wouldn't dare. So you can just imagine how freaked I was when I saw this. Let's see if I have it here ready. I don't. Okay, then I'll have to type it in. So let's do a simple one first. Driver query is a built-in built-in executable since XP. So I'm going to do a driver query, and then I'm going to pipe that in. And I'm going to pipe that to find, and I'm trying to find, I have written it down here for myself because I've never seen it before, MSGPIO Win32. Now let's go through the whole driver list of this machine and try to find that name, okay? And see what that might be. And it's something called Common Driver for Butt Kernel. I honestly have no idea what the butt kernel does, but with my Finnish and English that sounds horrible, so. My computer is apparently, someone's hogging the CPU and he or she is called a butt kernel, okay? That might be an easy way. If you have something like this, that might just give you an idea of how to find it. So if you can't spot it. Then what you can do after this is, of course, try and figure out it a bit more and try to find that same driver file. And if you don't know where that driver itself is, because driver query doesn't tell you the driver file itself, though, then you can go and start here, although you have to remember it might be somewhere else as well. So you might have to do this on the C root folder. But what I'm going to do here is I'm trying to find it from here, so drivers, and then you can do find string. For example, use find string, and I have the same thing here. Oh, sorry, first we probably need SML. So literal meaning it's case sensitive, S going through subdirectories as well. And I have no idea what M does anymore. Honestly, I don't even remember what it does. I learned those because my first name is Sami, my second name is Matti, and my last name is Laiho. So it's easy for me to remember those, but I have no idea what they mean. GPIO Win32. We're going to try and find that string from all the sys files. So it happens to be by the same name, so that's again, of course, kind of a horrible demo because it's too easy. But sometimes it's as easy as this. Many times it's not, so you still need to do this, okay? And you can use strings as well. I don't know how much you've used strings. Strings is an awesome tool by sysinternals, so it's a great one. Last time I used it was actually when we were debugging this thing with, I would bet that most of you have seen this, when Windows Update Client, WUAUCLT.exe consumes about 25% of your CPU. So the first time I went to a customer's site and I saw this, we started to experiment with the Windows Update Client, but we had no idea how it works, so we tried, of course, to find documentation. And if you encountered this, you probably know there is no documentation. So then you start going to Google. Oh. Bing. Do you have any idea how horrible that sounds on the recording? Okay. What we'll do is let's play around with this a bit. I went to the search engine of your choice, and I found Windows Update Client parameters. And then you start finding people telling you the weirdest stories on how this works. So there's detect now, will trigger a Windows Update detection. It really does. That's true. Then you have something called report now, which will actually contact the update server and report how it's doing. Then I started reading those, and it starts looking really weird because people start going to like detect and report now. That works as well. It can actually do anything you want. It's an amazing tool. So it can do some kind of magic that I thought would never happen during this week, which is it actually has this hidden parameter of Windows Update Client / make WhatsApp work at Ignite. And it does that as well. So it's kind of a weird thing. It has no documentation and it has no error detection. So really easy to use. Feed anything you want. You can have a lot of fun with your friends with this. Okay? So the next question, of course, what can it really do? So let's use strings and try that out. So whenever you have an unknown binary, whatever you're trying to find, strings will help you out. So let's do this. Wua.txt. And let's see what that looks like. And it doesn't take you long when you actually find the correct parameters. So they are easily found straight from the binary. So that's what they're. I have no idea how that demo UI works. If you use it, it says I'm going to reboot your machine in 3 minutes. But I've never had a chance to really let it, because I don't know if demo means that it will show me how it works, or a demo means that it's just demonstrating the user interface. I have no idea. But that is what it can actually do. Now we do the exact same thing with any drivers, but usually then what we try to find is, of course, some indication on who developed the driver, what the company is, and stuff like that. So it's a very good tool for investigating without having access to the actual source code. Okay, let's go back here. Now we should be getting to the next big topic. Finally, there's a few things you should always remember before we change to the next topic. So a few things you should remember. One is that performance monitor is in many cases told to be like the best tool to monitor. Well, it's kind of true in a way, because it's the only thing that can monitor several machines at a time over the network, for example, but it has some really big limitations. One is, for example, these cases we would like to know what processes take the CPU. But when you start performance monitor up, it will only show you, if you see it on the screen. You can do it in a binary log file or SQL, then it works, but if you do it on the screen, it will never catch up on the new created threads or processes. It's an image of the time when you started it. So if there's 100 processes at that point in time, it will show those forever. but if the process that actually consumes the memory is going away and coming back, you'll never catch it. That's a big issue in that one. Also, if you are looking at processor time, you have to remember that it shows a process's time including all threads of that process. So if the process has 8 threads, and every thread is taking 100% of your single logical processor, you can see values of 800%. And I've seen those, and it's really confusing. So it's not a really good tool for this. One more thing is something with our laptops mainly, not that much with your servers, but with your laptops you have to remember that there is nowadays the basic rule that a high CPU utilization, but using a lower clock speed, is actually lower than low utilization using the maximum clock speed. So your clock speed varies a lot on your CPUs, which means that if you use resource monitor, you can see it easily. So resource monitor shows you both the frequency of the processor currently and the load. So you can actually get reliable results from it. Hyper-V changes things a lot. So this is something I already kind of discussed, but this is something that people do all the time. For example, on my computer here that you see, my laptop, it's running Hyper-V, although I'm not using any VMs currently, but it's using Hyper-V, which means that actually my VM is on my hypervisor. I mean my interactive session, the one that I'm using, that's actually a VM. It's running on the hypervisor. It's called, the host partition, but it's a partition on top of the Hyper-V. If you've seen the slides which describe how Hyper-V works, you know Hyper-V is there below the host itself. That means that you can't measure it like a normal physical CPU. It's a virtual CPU, and if you look at Task Manager or even Process Explorer, it can't really tell you the truth about how much your physical CPU is used. If you want to measure those, there are tools that can measure those. Performance Monitor, for example, can measure those. So there are these CPU stolen time that can tell you how much actually is taken by this physical piece instead of your virtual machine. Why is it CPU stolen? I have no idea, but anyway. Yeah, it kind of steals it. It still sounds weird. Never trust processor queue length. That's probably one of the weirdest things, because many instructions tell you that this CPU queue length is something to look at, because your CPU shouldn't have instructions waiting on the queue that much. It should be able to process and keep the queue quite empty. But if it's a virtual machine, it has no relation to that really. So it might be like 30 or 40 and everything's fine. Because it's a scheduler, it's not a physical processor, so it doesn't work the same way. The next topic, memory, which is a huge topic, and some basics first. And I try to add as much as possible concepts that people get wrong, which usually ends up you doing performance troubleshooting the wrong way. So virtual machine is, first of all, something that was designed to never run out of. Every process gets 2 gigs of memory on a 32-bit machine. Although if you have 512 megs of memory, all your processes will think they have 2 gigs. So it's trying to hide the actual amount of physical RAM plus page files so that you can run more software even if they are trying to acquire a bit more memory. So virtual memory is something that's on all boxes. There will never be a Windows that doesn't have some sort of virtual memory. Virtual memory works in a way that you can think like if you were wearing one of those cool new HoloLenses. So the memory manager tries to keep everything that you need or it thinks that you will need quite soon. It will try to keep that in your physical memory. But it is meant to optimize. So when it thinks you're not going to use it, it will try to move it somewhere else so that you have physical memory for other more important stuff. So if you think about a HoloLens, when you turn around, the HoloLens draws those cool holograms that you see. It's quite sure that at any point of time you might turn your head and watch back, and it still would need to show you the contents of that room. But if you change from a room to another and you close the door, it can be a little bit more relaxed because it knows that before you get the chance to open the door, open it, get in and look at something, it has time to get it back into the memory. So Virtual Memory Manager is trying to do the same. It's trying to optimize. Now people, sometimes I don't understand, but people seem to hate optimization because people tell me that they just want to take the page file off because they want their computers to run better without the page file. I'm going to talk about the page file in a while, and that's something that I totally disagree on. Now that we got to the topic of page file, that's a really funny thing because if you look at the user interface, it actually says on the page file settings, it says virtual memory. Although page files have nothing to do with real virtual memory. If you take the page file off, you will always have virtual memory. It doesn't have anything to do with that. It's kind of virtual memory because it's not real memory. Yeah, I get the point. But still, it has nothing to do with the actual concept of virtual memory. Because virtual memory will always be there anyway. Something that you should take a look at, which is viewable even in Task Manager, which is the commit size and commit limits. Those are memory. Commit limit is actually the maximum amount of memory that your operating system can commit to give you if you would need it. So it commits if needed to give it to you. That's why it's called committed. It doesn't have anything to do with used memory, because memory only gets used when it's touched. But first it's committing that I will give you this amount if you want it. Maximum amount, which is seen as the commit limit, is the number of the amount of RAM you have, so your physical memory plus all the possible 16 page files that you can have in a maximum installation. So that all will end up being your commit limit, meaning that's the biggest thing that the operating system can commit to anyone to be able to give you memory for. And then there's the commit size, which is currently in use, meaning that it's at the time it's committed that to someone else already, but it actually isn't used in the physical memory because probably it hasn't been touched yet. So only when it's been touched, when it actually consumes memory. There's the virtual memory, as you can see it on the current operating system. Nothing to do with the virtual memory, but it still is there. Virtual memory has changed drastically between the current the latest operating system versions. This is something that I think people don't really even know, many of them, which is that they will tell me all the time that there's really no difference in the kernel between Windows 8 and 8.1, although there is probably one of the biggest changes in the history of Windows. Because here you can see examples taken from VMMap, which is a free tool from sysinternals, and you can see that they're actually, on the left-hand side, you have a 32-bit notepad running on a 32-bit OS. But it doesn't really matter where it's running because it's a 32-bit notepad anyway. So it gets 2 gigs, the maximum amount of memory. That's the amount that's free actually now, but it sees 2 gigs. Then we change and we take a 64-bit notepad running on Windows 8 or Server 2012, and you grow up to 8 terabytes. Your virtual memory for every single process that's running on your machine is 8 terabytes. As we discussed, it was never supposed to be it was never supposed to run out. Windows on a PC is supposed to work so that your physical memory can run out, but Windows will never have a problem of virtual memory running out. And you have to remember that back in 1993, most of the computers had 8 megs of memory. That's why 2 gigs sounded as big a number to people then as probably the new values sound to us. That would be, that would be the stupidest thing to ever say, that we will never run out of 8 terabytes of. It's like someone used to say that the PC will never need more than 640K of memory, so and they were wise people. That's kind of saying that, when we get IPv6, we'll never run out of IP addresses. Sure. And by the way, I didn't say that. That gets recorded, and you're not going to clip that out and tell that Sami said this. And now you will do it, I know. Okay, so 64-bit notepad, but it's running on the right-hand side on top of 8.1 or Server 2012 R2, and it has a virtual memory of 128 terabytes. which means that now finally you can't blame Microsoft of not being able to use the memory. Everyone was laughing about the old one. Old one was 16 terabytes, meaning 8 terabytes for kernel and 8 terabytes for user mode processes. And people were complaining that, 64 bits can actually do a lot more than your 40 bits that you are actually using. So why are you telling that you're using 64 bits? But now they are actually using 256 terabytes of virtual memory. So now we are very close to the actual 64 bits. So, like what's possible, basically. What if you have this old software that only can address 32-bit as a value? If you change it from a binary mode to a decimal value, you can see that you can't really show anything bigger than the 4 gigabytes. So that's why it was divided into 2. So 2 for user mode, 2 for kernel mode. And then Exchange was one of the first ones. Exchange and SQL Server started to demand more user mode memory, so Microsoft came up with this last 3GP switch. And after that, it was a BCD store entry of increase user VA. Those can change it so that your user mode gets 3 gigs and your kernel mode gets 1 gig. My only recommendation, do whatever you can to stay away from that. The problem lies in the fact that you can have a server easily with like 16 gigs of memory nowadays. That's not anything. But if you have 16 gigs of memory and you have to use a 32-bit OS on it, you can use the 16 gigs of memory because we've got these things like large address space aware processes. We've got physical address extensions, PAE, stuff like that, that gives you the ability to address more than 4 gigs of memory on a server. But although you're addressing more memory, every single memory page that gets translated from virtual memory to actual physical memory requires a small amount of data to be written into the memory. And it needs to be in kernel mode, and it needs to be non-paged pool, which means that it needs to be in the physical memory. So if you have 16 gigs of memory, you actually consume 112 megs of your memory only for the database that tells where the pages really are. And if you think you only now have 1 gig of memory for your kernel, because you used 3GP switch, for example, that's a huge amount, over 10% of your memory only to actually address the memory before it can be used. What you should do is migrate to a 64-bit OS and use what's called large address space aware flag, which by Microsoft's official statement says that it's relatively safe to use. We all trust that, so I'd say test it first, but you can quite easily turn it on even on software that doesn't support it, which means there are 2 tools that I know. One is the one you can see here, which is the dump bin, and then there's something called img config, img-cfg.exe, which can change the process to use up to 4 gigs of memory if you're running on a 64-bit OS, even if it's a 32-bit process. So that's what you should be doing rather. If you need to think about running out of memory, you also have to remember that you can run out of memory in many, many different ways. So a process can run out of virtual memory, which is really odd on a 64-bit OS, because you have 8 terabytes or 128 terabytes of memory to spare, so you shouldn't be running out of virtual memory. But it of course can be. What is more common is that you can't allocate the required amount of memory which needs to be in a single contiguous space, because memory has fragmentation as well, like old hard disks. So you get memory written to different places and you don't have a contiguous place in the memory to put the big pile of memory that you need. So that's more common than actually running out of virtual memory. That can be viewed with VMMap, for example. Out of system commit memory, committed memory. So that's something that's easy to kind of find out, because you just use your task manager and you have 2 values, commit size and then you have commit limit. So your commit size should never reach your commit limit, and you are safe if that doesn't happen. What starts to happen is that if you have a memory, if you get a memory on an error on Windows that says you're running low on memory, that means that you reached your commit limit but your page files can still grow. So you haven't changed your page files to static sizes, or they haven't grown to their maximum size yet, and you have disk space. Then it will actually automatically grow the commit limit. And then only when it reaches the commit limit and you have no space to grow your page files anymore, then you will get the out of memory. Not low on memory, but out of memory. You can even see this on the event IDs if you want. So I've listed the event IDs here just because I personally do some monitoring on events, and event triggers are used for those. So if you want to see the physical layout of the memory, now the last one I talked about was VMMap. VMMap is meant to see a process's virtual memory. And it takes a process at a time. And it looks like the pictures you saw earlier on the slide with the 8 terabyte, 128 terabyte. If you want to see physical layout of your memory, like are your drivers consuming your memory maybe, then you need RAM map. The RAM map is also a sysinternals tool. Now, you can be running out of kernel memory, which is very uncommon because of the huge amount of virtual memory you have on 64-bit machines, but 32-bit machines nowadays that we still have to run on our customers in many places are actually quite common to run out of kernel memory. And that's kind of maybe a bit easier to see and spot, so we can actually, I'll show you a demo in a second about that, so we can see that happening. There's two different memories in kernel. I mean, two different types of memories that the kernel uses. It uses a pool that's called non-paged pool. That means that it has to always stay in the physical memory. And then there's a paged pool, which means that it can be paged on the disk if needed. And you can run out of either of these. You can use Process Explorer. I'll show you in a second. And that will tell you if you're reaching a critical value of 75% of your maximum. Then you should investigate more, but then you will have to change to another tool because Process Explorer can't show you what's really happening. And I'll show you, for example, I'll show you an example on Poolmon. That's a tool that we can actually look right now. I still have the tremendous 7.5 minutes to go. Okay. We should have I'm going to try to see on which one are they. I think they should be here. So let's try, actually, sorry, here, there's Poolmon. What I'll do is I'll start Poolmon, which can monitor the pools, and then I'll actually press B for basic. Well, actually it just categorizes these in an order that we can see the ones who are using the biggest amounts of memory. And what I'll do next is I'll open up Not My Fault from sysinternals to cause some leakage on this machine. So let's leak some memory. Let's leak it a bit faster. I hope this one doesn't crash on me. And let's start leaking. And if you go here, and wait a second, you see someone here climbing up the ladder quite quickly. And why is this used and why am I showing you this? The reason is because what is really important here is this one called the tag. It's called a pool tag. And that one, I'll stop this before this freezes because this will totally freeze the box in a second. It has a tag of leak and it's case sensitive. So big L, capital L, okay? And now we can use the same measures we did earlier. So what you can do now is you can actually use find string SML leak and try to find that from all the drivers. And because this was caused by Not My Fault, which is just a demo program, we can easily see that it's actually myfault.sys, which is the driver that Not My Fault uses. So it's not that easy to find leaking programs and taking them with you on your laptop that you wish will work for the whole demonstration. So that's why it's it's just a demo program. Leaks when you want it to leak. There's kind of few slides that I have on disk troubleshooting, a few tools on disk troubleshooting, and a few tools on network troubleshooting. So I'm going to actually, so that I have time to tell you the page file stuff, I will tell you that there are a few more slides that I have time to go through. So there are a bit more slides because I know all the slides are available to you, so there are a bit more. Those are the ones that have lists of tools which we don't have to read aloud here. You can read them by yourselves. So we'll talk about a few things still. One, the page file thing. Do you need a page file or not? Page file has three main functions. One is to make it possible for applications to run even if you are running a bit low on your physical memory. It gives you the most important thing, which is the ability to record a memory dump when needed. And then it has the third purpose, which is to just optimize, move data out of memory which doesn't need to be there. Now people are really, this is something that people tell me, that there are as many different opinions on this as there are speakers. Seems that everyone has their own opinion on how to do it. So I'm kind of a troubleshooting guy, so I'm really focusing on keeping you in a place where you can, if needed, record those memory dumps. So those are kind of my main thing. I have taken this straight from the Windows internals book. So that's just what Mark says. So I need to, I hope you are starting to trust me. But as long as you don't, I have proof that Mark agrees. Okay. So you can read that if you want, but it's basically load your machine to run whatever it needs to be run on a maximum load, check what's your commit limit at that time, check that you have what's your commit usage at that time, and make sure that your RAM and page files can house that needed commit limit or commit use. What about no paging file? That's a ridiculous thing to do if you ask me, unless you have a good backup plan on what you do when Microsoft support tells you that they need a full memory dump of your machine. If you do that, you show me the plan, I'll accept that. But otherwise, if you don't do that, it's just silly to take off your page files, even if you have huge amounts of memory. There are reasons for that. One thing is that taking away page files doesn't take away paging. There's three different ways that a computer or Windows operating system pages stuff out to the disk. So it's just one of the third. One out of three, okay? I'll show you the rest. Page file is not used if it's not needed. Windows doesn't advertise to processes like, hey, I have slow page file here, use that rather, please. So that would make it the stupidest OS in the world. Don't say anything about it. Okay, so why is removing the page file a net loss? You can easily run out of virtual memory, although you have a lot of free RAM. That can easily happen. So it doesn't really, you just have to remember that virtual memory is a different thing. If someone's talking about page files and say they're virtual memory, yeah, in a way. And here's the reason why. So if you look at this one here, on the left-hand side, we still have a page file. So this one you see in the middle, that's a virtual address space of a process. I've got the permission from ASUS, US company, to steal their slides, because I don't want to draw this again. I get the question quite often that, do you ever go to a training yourself anymore? I go to their training. So guys used to work for David Solomon before he retired, and I don't know if you know the guys, but anyway, they're writing the next Windows internals book. So they know their stuff. Virtual address space in the middle, and then on the left-hand side we have what's called packing store, so our hard disk basically, and on the right-hand side the physical RAM. Now, what we have in the memory is we have a lot of, in the memory we have stuff which is non-pageable, so our kernel needs some memory anyway. Then we have private committed, which is memory used by processes that needs to stay in the memory. Some of it gets into the page file. And then we have memory mapped files, usually ORIOL executables, DLLs and stuff like that, that can be easily shared. Those are all on your hard disk as well. They're just mapped into memory. Now, when you take away your page file, what actually happens is that you don't have a place to put your private committed bytes, which are the processes needing their memory. So that needs to all stay in the physical memory itself, which squeezes this amount of memory available for mapped files, which increases the times that this has to be read. So you're reading more on the disk because of the mapped files, although you are saving on reading the page file, yes. So there's it's a net loss anyway. Performance monitor doesn't have a clue if you really need it. I'm going to end this thing with a simple thing of how do you really know how to use how do you really know if your page file is used or not? Okay? And when I'm talking about simple, I'm going to show you a final thing about Finland, because we know what simple is. We're very good in simple. I had to put it here because everyone's talking about it on Facebook, so I just had to do it and show it to you as well. Because I had this guy sending me a Facebook link of different capitals' subway systems. Different countries' capital subway systems. That's the subway system of Tokyo. I don't know if anyone's from there. It's not that simple. Then we have a European, another one, which is from Paris. That's the Paris subway. That's not that simple. This is from Helsinki. That's simple. I do hope that you all fill your evals. I hope you do read this slide as the last one. There are a few good tips what you should do after this. And there's a guy called Clint Huffman that I want to tell you about. Go and read his book. It's on Kindle, for example. It's the best one you can have on performance. And when you read that, you can download his tool, which is good as well. But the book is just excellent. Now, if you've got the business cards ready, I got the beanies ready. Thank you.